So what are some typical fossils? One is going to be bacteria. Now you might think that you would never be able to find fossilized bacteria because bacteria are microscopic. Well, you're right, but we can find the mounds that they made. So these things are a kind of photosynthetic bacteria, and what they would do is they would grow on top of a rock, and part of the day they would be out of the water, and then part of the day they would be underwater. So they would live on the shoreline of an ocean. Then as these bacteria, which are on the surface of this thing, as they would die, then more sediment would fall on top of them, and a new layer of bacteria would then start to grow on top of the remains of their brethren. And then as they would die, more sediment would fall on top of them, and then you'd have a new layer. So you have layer after layer after layer of this sediment that then hardens, and you have a rock. So these mound-like structures are the bodies of all of these photosynthetic bacteria. Now later in a future lesson, we're going to talk about the history of life on Earth, and these things were very important in pumping oxygen into the Earth's atmosphere and altering it. So another kind of fossil that you can sometimes find is a coral. And these are animals, and they live in colonies, and they're filter feeders, so they can pull stuff out of the water to eat, and then they make their bodies out of calcium carbonate, which is really good because then when they die, then we have the remnants of their bodies. So you'll notice that the picture on the left is the fossilized version of coral, and then the picture on the right is an actual one. Similarly, on this picture here, the picture on the left, that's the fossilized version, and then the picture on the right is an actual one from Australia. Okay, another one is, this is going to be called the phylum Bryozoa. So notice it's still going to be considered an animal, even though it kind of looks like a plant. But it really is an animal. It's, again, a colony of animals that would be filter feeders. Okay, now here is an animal that makes a shell out of calcium carbonate. So there's some fossilized brachiopods, and then off to the side there on the right are actual ones. Okay, then you've got the phylum Mollusca, and so the first one is going to be bivalves. So bi means two, so it's going to have two pieces that come together like this, and so an example of that would be an oyster. You also have gastropods, and so an example of this would be a snail. And so there's a fossilized snail, and then there's a real snail to the right. And then you've got cephalopods. So the fossilized cephalopods would have been octopi, that would have had a hard shell. So if you can imagine that shell and then tentacles coming out of it. Now later, they decided to lose the shell in order to be faster. So that modern cephalopods, they don't have an external shell. Okay, another thing that you can find are trilobites. And so a trilobite is a great ancestor to the insects. And so if you've ever seen a roly-poly, so those are those things that have multiple legs that come out, and then if you scare them, they curl up into a ball. So these trilobite things could do the same thing. These trilobites would live on the ocean floor, and they could either crawl on the ocean floor, and then there were some that could actually swim through the water. And again, they were pretty much filter feeders, so they would get little particles of food and digest them. Okay, here are the crinoids. So what these are, they're still animals, and what they would do is they would have a stalk that would be attached to the ocean floor, and then they would have a head, and then coming out of the head would be tentacles. And then what they would be able to do is they could grab little pieces of food from the water and pull it towards their mouth, and then they could digest it. Now the problem, and the whole thing is made of calcium carbonate. So these discs are made of calcium carbonate, the head's made of calcium carbonate, the tentacles are all made of calcium carbonate. So they lived close to the shorelines of oceans in relatively shallow water. So a modern example of one of these things is called a sea lily. And so that's a picture of a modern day sea lily, which is related to the crinoid. So when these things would die, they would tend to fall apart. And then wave action would be pounding on them. So all of these discs would get all mixed up. So here in Missouri, especially around Springfield, Missouri, we have lots of limestone that consists of nothing but these kinds of discs all smashed together. And so it's a very rare instance that you would find a crinoid that is complete. So that fossil over there, you can see the stem, you can see the head, you can see the tentacles. And so if you ever do find a fossil like that, make sure and sell it on eBay, because it's worth a lot of money. All right, let's take a break, and when we come back, we will talk about why do fossils change.